Hello guys, welcome back to my channel. So in this video, we will be learning about permutations and combinations. So the problem that we will be discussing today are problems, those are based on circular permutation. So let's get started. So before jumping into the first question, let's understand a very basic difference between a line arrangement and a circular arrangement. Now, for a line arrangement, we know what is right of the line and we know what is left of the line. But for a circular arrangement, right and left is not defined until one person comes and sits on that circle. So while solving problems based on circular permutation, always remember that you need to place one person first on that circle, and after that you will start arranging based on that person's position. So it is very important that you need to place one person first. Let's start with the very first question. The question goes like, 5 people are to be seated around a circular table. Find the number of ways. Now, let's consider a circle. Now, as I just mentioned, you need to always place one person. So, I'll be placing one person. Now, we are left with 4 people and 4 places. So, the solution goes like, since we'll place first person first, so it will be 1 into, since we need to select 4 places out of 4 places, that would be 4C4 into, now you need to arrange 4 people, so that would be factorial 4. So if you just simplify it, 4C4 is always 1 and 1 into factorial 4. So you can always remember a thumb rule, which is n minus 1 ways, n minus 1 factorial ways. Now whenever you need to do a circular arrangement, you always remember that you subtract 1 and that factorial ways gives you the result if everyone would be seated. The thumb rule goes like, number of circular permutations of n distinct things taken all at a time is equal to n minus 1 factorial ways. What do I mean by all at a time? Well, it means that all of the distinct things need to be arranged. For example, if we have 10 persons, all of that 10 person need to be arranged around that table. Only then will this rule work. Now let's jump into the next question. Person A is sitting around a circular table. Find number of ways of arranging 10 persons around this table. Now, the very first instinct, you will give the answer as factorial 9 ways. Well, this is absolutely incorrect. You need to remember that there is already one person that is sitting on that table. So that arrangement would not work, but the solution would be 10 factorial ways. So always remember to read the questions very carefully while solving questions on permutations and combinations. Moving forward, the next question is 10 persons P1, P2 up to P10 are to be arranged around a circular table. Find number of ways if P1 and P2 are always together. Now whenever we hear the term always together or always separate, always try to connect it with string method or gap method. So in this case, since P1, P2, P3 are always together, we will go with the string method. Now, if you're not being able to follow this video, please go check out the gap method and string method video first. I'll be attaching the link in the description. It is a really important video. So please do check it out. So now for the string method, we will be having 8 packets. The 7 packets and P1, P2, P3 would be considered as one packet. Now, for circular arrangement, we know that the arrangement would be equal to n minus 1 factorial. So it is 7 factorial into internal arrangement of P1, P2 and P3. That would be factorial 3. So the product of both would give us the result. Please do check out the video of string and gap method so that this video would really make more sense. Moving forward, the next question is when P1, P2 and P3 are always separate. Now, if it is always separate, we go with the gap method. Now, since we need to arrange 7 people first because we will be arranging all other people apart from this 3 people. So, it is 6 factorial ways that we have learned just from in the thumb rule. Now, we have to arrange P1, P2, P3. So, if we count the number of gaps, we have 7 gaps. And in this from this 7 gap, we need to choose 3 gaps in which this 3 would be arranged. So that would be 7C3 is the selection and into factorial 3, that is the arrangement. So our final solution is factorial 6 into 7c3 into factorial 3 ways. Moving forward, the question goes like 7 boys and 7 girls are to be seated around a circular table. Find number of ways if no two girls are together. Now no two girls are together or always separate means the same. You have to go with the gap method. Now first we will be arranging the boys. So if we arrange the boys, we know we have 7 boys, so that would be factorial 6 ways. Now for arranging of girls, we have 7 gaps. If you count the gaps, those are 7. So we will select 7 gaps out of 7, that would be 7c7, and we will be internally arranging those girls also, so that would be factorial 7. So the solution is factorial 6 into 7c7 into factorial 7. Now the next question is a little tricky. The question goes like, find number of ways if boys and girls are alternate. Now the same question I have also explained in case of a linear arrangement, but there is a slight difference when it comes to a circular arrangement. For a linear arrangement, the starting and the ending position has some significance. But for a circular arrangement, since it is a circle, we don't exactly have a starting and an ending position. So, girls not being together or boys and girls being alternate, the solution would be the same. So again the solution goes like, we can pick either the boy or the girl and start arranging them first. So that would be factorial 6 ways. Now whichever is left, either the boy or the girl, so we will be having 7 places to arrange that. So we will be picking from those 7 places, we will be picking 7 places, that is 7c7 into factorial 7, that would be the internal arrangement. So I hope it is very clear that for a linear arrangement, the solution would have not been the same for alternate and not together. But in case of a circular arrangement, both the questions are exactly the same. I would really request you to check that video out once. I would be attaching the link in the description, and it will give you a really good perspective on the difference between a circular arrangement and a linear arrangement. Now we have come up to the last question of this particular video. The question goes like, 5 boys and 5 girls are to be seated around a circular table. Find number of ways if boys and girls are alternate and B1 and G1 are always together. Now this question seems to be a very complex question, but we will be dividing this question into different parts and try to solve each part independently, and then we will club this. So it is not a very difficult question. Let's just start with it. So let's start by arranging other people apart from B1 and G1. So the first part is arrangement without B1 and G1. So now, as this is pretty much like the previous question, that would be factorial 3 into factorial 4. That is, first we will be arranging either the boy or the girl, and then we will multiply it with the arrangement of the other which is left. And this is a pretty similar question. Now we'll make it a little complex. That is by arranging only B1 and G1. Now, since if we see, we have already arranged 8 people. So now the number of gaps are 8. So from this 8 gap, we need to select one gap in which B1 and G1 will be sitting. And then we will not be multiplying it by 2, but we will be multiplying it by 1. Now there's a very important catch. Since B1 and G1 has to be alternate, we know already a boy would be sitting at one side and a girl would be sitting at one side. So if we need to maintain that alternate position, we can't make B1 and G1 switch amongst each other. I hope you are trying to understand. Already others are sitting. We have already selected one gap in which we will be placing B1 and G1. Now, but we can't do actually the internal arrangement of them because we have to maintain the alternate also. So that would be into 1. Now the final solution is just the multiplication of both, that is factorial 3 into factorial 4 into 8c1 into 1 ways. I hope this was a really important and really helpful video. So this is pretty much it for this video. I would be coming up with more videos on this topic as this is a very vast topic and I have just given a basic introduction to this. I didn't want it to make this video really big, but if you have any doubts or concerns regarding any of the questions that I have explained or otherwise, feel free to drop down your comments in the comment section below, and I would be really happy to help you. And for more such videos, please subscribe to my channel. Please give this video a big fat thumbs up. Thank you so much.
Like, share, subscribe. Press the bell icon and follow us on Instagram to get notifications for our latest videos.